Hi there. Yeah, this is Cyril Rachan from Solomon Islands, presenting investigating the littoral transport of sediment along the Nasese Coastline in Suva, Fiji Islands. So this is a research done along with the students, and we're trying to find out what happened to the sediment along that coastline in Fiji, the main place where lots of activities always take place there. Well, the main focus there is with regards to the port. The Suva port is one of the biggest port in South Pacific, so it's like the main hub, and then most of the Pacific Islands rely on this main hub also. Then this research is actually trying to find out what happened to this coastline and the sediment along. So it's about 4 kilometers, and it's located where most of the recreational, and it's the closest to the biggest port, which is the Suva port in Fiji. A bit background on that, this research aims to study the properties of the coastal sediment profile. So we have these about 4 kilometers. We actually section them to 11, and then we trying to find a profile here, pitch profile, and then we determine what are the existing sediment and also particle sizes. And from this, we're trying to actually indicate what are the high tendency of littoral transport, whether it's towards this port or towards the campus here. So if it's towards this one, then we're trying to actually mitigate the rate of deposition of sediment at the port. Now, some few research done already on those places. A two-dimensional hydrodynamic numerical model done by Rachan in 1996. Well, he just actually shows the flood velocity patterns. So you could see from generating the numerical model, the flood tend to go the other way around out of Suva port, and then but few also coming through this area also. That was for the past 20 years, and he continues to actually did 6 of the beach profile to actually study the profile of the coastline, and eventually he comes up with one of those profiling, and this is where the landward is, and this one is towards the seaward, and then it comes across some of these ones here. The difference is that for this research there's more than one of this profiling been studied. Now, background of the research is also regards to SING 2006, conducted the same coastline, however, basically for salinity, temperature, turbidity, and suspended sediments distributed along the lagoon. And you could see the also here. So in this case, the indication here is that for the sediment is more sediment brown. So actually, it's a good thing to study along here and towards this port. Now, the method that is planned for the research was this is the area in Fiji Island we studied, and then we gave some sections, and then all those samples with sediments. We collect them and do it in the civil lab to get the particle size distribution. And that's under the Fiji National University in Derry campus. One of the interesting part in which we are trying to study is we are trying to actually look at the lowest low tide, and then from the site we found from the website we can determine the lowest low in these times, and then we could go and then do our measurement for using the survey equipment. The thing is that we don't have those echo sounder for deeper place. So I'm trying to use as much as possible the survey equipment so that we can get the topo during the lowest low tide, and then we can determine what are the sediment or the changes in the profile from one day and then to the next day. So this actually helps. So what happens is that we have to be there before the lowest low tide so that it gives us more time to actually use those time when water is very low. And these are the sections in which we decided to study. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sections. It's about 4 kilometers. And from all of them, then we come up with a few, which is better to study. The reason being some of these things there that it's not to stretch the area, it's only short. So and then it goes really deep. So this one's more better, and it's having quite similar lengths, so it's easier to study. So we have those chains 1900, 23, 2700, 31, and 3500. And from here we could study how's the relationship of the beach profile. And got the samples also. Now for the first day 2, day 1, we had results, and we decided to take a day 2 and study that. So from day 2, we could see that those chains here, these are the baselines from the first day we took, and then we wanted to see what happened on the next day. So on the next day, we see that from 1 to 2, that means from the day 1 to day 2, actually this party increases. Now what happened is when it increased only, the arrow shows just the amount of increase there. So the amount of increase is much bigger than the blue one. So this one is much bigger than the blue one, but the green one is actually decreasing. So what happened is when this one here increase, that means this one decrease. So this decreases, actually it's either going to the right and also going to the left a little bit. However, the thing is that from this end here shows that there's a lot of increase here. So that means from this side, only few going to the right, and to the left is going up, few here and more here. And over here it doesn't show. But these two actually indicates that the sediment's been moving from this end going there more than that, only few. So the same goes to yellow and red going that way. And then later we find that other part too also from this one decreases, and then also this one is actually statement same, but the green one and the white one, this one decrease and this one increase. So when the white one decrease and then this one increase, that means from here travels to the green. So it's actually going to the direction. So this is one way in which actually indicates that the sediment is traveling from the lower campus to the port area. The other one is we use the particle size distribution, getting the sizes of these ones to actually determine what happened to. So I decided to choose these three here, and then I did the PSD, particle size distribution, of those three. And we found that from the change 15 and 60, those all three of them, change 60 of all three, and then I just studied what happened to the sediment. So what happened to the sediment is that the same one here, combined it with the second one, and then combined with the third one. So what happened is that it actually increased for the same one. For this one to the Chinese 27, it actually increase in the fine. I mean, this when it goes towards the right, you could see it's getting more finer. So when it's getting more finer, that means the more more waves and then actions going towards this the port. So that means when it goes this side, so that means most of the sediments being washed away towards the port. And third one and final one, I'm just trying to use wind data from meteorological office in Fiji, and then got the October and November wind data, and then using the windrows and I come up and generate this more wind blowing towards this end here. So therefore, from the wind actually shows that more waves are going this side. So definitely the waves actually carrying all the sediments or suspended solids going towards this super port. So definitely from my research, I can say that few of these things are continuing to go towards the port, in which the dredging will be done like more often. So we need to actually mitigate this one. So I just come with some ideas that, okay, since we know most of the wind and then the sediment going towards the port, so we might as well use the groins here, so coastal structures, to actually reduce the rate of sediment reaching the port. By the time it reached the port, maybe took maybe 5 years to do another dredging and save costs. Yeah. So actually, this idea helps a lot just by using survey equipments and a few other tools, windrows and the PSD, particle size distribution, in the civil lab, and we can actually help to determine the movement of the little sediment transport in any of the Pacific Island coastline. Yeah, thanks, survey team, and thank you very much.